Good morning student. Today I am going to start next chemical reaction, single displacement reaction. Here displacement means to move something from its place. Let's understand it with an example. Suppose you are sitting on your place in the classroom with your friend, and if any other student of your class asks you to get up from your place as he wants to sit on that place, what will you do? Here two things can happen. First, if a student is weaker than or same as you, then you will refuse. But if he is stronger than you, you have to leave your place. So here we can say strong can replace weak and more reactive things can replace less reactive thing. Same thing we can see in displacement, single displacement reaction. In single displacement reaction, more reactive elements displace less reactive element and take a place of less reactive element in a chemical reaction. This reaction is called single displacement reaction. Let's understand with an example. Here in the picture we can see that A is an element and compound BC. Now A is more reactive than B. So A go to displace B and combine with C. Now B is alone here. So we have AC and B. This is the single displacement reaction. As we saw here, more reactive element A is displacing less reactive element B. Here you must be remember that if element is a metal, will replace the cations, and if element is non-metal, will replace anion. Here a question comes that how do we know which elements is more reactive than the others? In chemistry, we have two different type of activity series for metals or non-metals. Let's see, this is the activity series for metals. Here we can see that metals present on the top of the series are more reactive. When we go down, reactivity decreases. For example, sodium and potassium are more reactive than the iron. Here we can see hydrogen is also in the list, even though hydrogen is a non-metal, but it is electropositive, so we can displace it by the metal. There is also a series for non-metals. Here we see that fluorine is a more reactive and phosphorus is a less reactive because it is present on the bottom of the series. Let's see some examples of single displacement reaction. See, in first example, this is the equation of non-metal displacement reaction. Here chlorine is more reactive, so it can replace bromine from the compound sodium bromide and we get sodium chloride and bromine gas. And in second reaction, this is the example of metal displacement reaction. Here Cu is more reactive than silver, so it replaces Ag means silver from silver nitrate solution and we get copper nitrate. Here you must be remember that metal will only replace metals and non-metals only replace non-metals. Here we are taking blue colored copper sulfate solution in a dry test tube and put iron nails in it and leave for a week or overnight. Think what will happen? We can see or observe here the blue color of the solution change to light green and brown colored copper metal gets deposited over iron nails. Here the chemical reaction would be Fe plus CuSO4 give us FeSO4 plus Cu. That means iron is more reactive than copper because iron can displace copper from copper sulfate solution. Let's see which type of questions will come in an exam. So here an incomplete equation is given and the question is, will this reaction occur? And the answer is no, because magnesium is more reactive than zinc according to the activity series. Let's see another example. Here in this single displacement reaction involving halogens, and the question is, will this equation occur? No, because iodine is less reactive than bromine. Now next is double displacement reaction. To understand this reaction, just look at this example. Here we can see A and C are friends, which are written in red color. Sitting with two other friends B and D, here we can see two groups AB and CD. After some time, A wants to exchange his place with C. Because they have similarities, that's why they are exchanging their place. Now we have two different groups CB and AD. Same we can see in double displacement reaction. In this reaction, two different atoms or group of atoms are displaced by other atoms or group of atoms. We can say two atoms exchange their ions. And one of the product formed is insoluble, that is called precipitate, and this reaction is called precipitation. Here, precipitate is an insoluble product that obtained during the chemical process and settle down after some time in the test tube. Let's see an example. Here we see that when sodium chloride dissolve in silver nitrate solution, then we get silver chloride and sodium nitrate. Here silver chloride is insoluble in water. So it is a precipitate and settle down in the test tube. Here this is the displacement reaction. So the two cations must switch. That's why sodium and silver will switch. Here both have 1 plus charge, so that ratio of anions does not change. And the skeleton equation is same as balance equation. And in second example, we can see that when potassium sulfate and barium nitrate are mixed, we get potassium nitrate and barium sulfate. Here we can see potassium and barium exchange their places. Look at this activity. Here we are taking 3 ml of sodium sulfate solution in a test tube, and also we are taking 3 ml of barium chloride solution in another test tube and mixing both the solution. What will you observe? You will observe that a white substance which is insoluble in water is formed. Here this insoluble substance formed is known as precipitate, and this type of reaction is called precipitation reaction, and this is the displacement reaction. Now next is oxidation and reduction reaction. Student, in your daily life you have seen that the surface of copper vessels become black when left for some time in open, and iron articles are shiny when new but get coated with reddish brown color when left for some time in open. The question is, why has this black colored or brown colored substance formed? Just because of redox reaction. Here redox means oxidation reduction reaction. Red means reduction and ox means oxidation. Student, In some simple terms, oxidation means addition of oxygen and removal of hydrogen, and reduction means addition of hydrogen and removal of oxygen. There are other ways to define oxidation and reduction. Let's see in this table. Here in this table we can see different type of definitions for oxidation and reduction reaction. Here we can see that oxidation is defined as addition of oxygen and reduction is defined as a loss of oxygen. And also we can define oxidation, removal of hydrogen, and reduction, gain of hydrogen. Here in third step we can see that oxidation is defined as loss of electron and reduction is gain of electron. And in the last, oxidation is defined as increase in oxidation number and reduction is decrease in oxidation number. To understand oxidation and reduction, you should know what are the oxidized and reduced compound. Here, the compound gains oxygen and loses hydrogen during the chemical reaction. It is said to be oxidized compound. And when the compound loses oxygen and gains hydrogen during the chemical reaction, it is said to be reduced compound. Here, A is an oxidized compound by losing electron and B is reduced compound by gaining of electron. Look at this example. Here we see when copper metal comes the contact of oxygen, copper oxide is formed. But when hydrogen gas is passed over this heated copper oxide, the black coating surface turns brown. As the reverse reaction and copper is obtained, that means addition of oxygen is called oxidation and removal of oxygen is called reduction, and also addition of hydrogen is called reduction. Here copper oxide loses oxygen and gets reduced, and oxygen add with hydrogen gas, so it gets oxidized. The best example of redox reaction is rusting of iron or corrosion. The metal which is reactive, its surface is attacked by air, water and other substances which is present around it. It is said to be corrode and this process is called corrosion. This is the best example of redox reaction because metal gets oxidized to metal oxide and oxygen gets reduced to oxide ion. For example, rusting of iron and formation of green layer on copper surface. And next is rancidity. Student, you must have observed the taste and smell of spoiled food. Why does the food get spoiled? When fats and oils are oxidized, they become rancid and their smell and taste changes. Here, this chapter is completed. So, the student, you will prepare your notes in your notebook.